Hey, welcome back to Mr. P Helps with Precal. This is Unit 1, Topic 1, SL5, and we're talking about limits and discontinuity. A is a infinite discontinuity, and the reason I know that is because I can tell based upon the fact that from the left-hand side it's going down towards infinite, down towards infinity, and from the right-hand side it's going up towards infinity. So the limit of f of x as x is approaching that would be at 0. As x is approaching 0 from the right-hand side, then it's going towards positive infinity. And if it's coming in from the left-hand side, it's going towards negative infinity. And then for b, we have here, this is removable. And the reason I know it's removable is because it's basically a hole that's in that line right there. So as the closer and closer you get towards, as x, it's removable when x is 2. So then as x is approaching 2 from the right, and then it's going towards 0.5. As x is approaching 2 from the left, then it also has a height of 0.5. And letter C, so this one is a jump. The reason I know it's a jump is because it's going from here, from a height of about 0.5, all the way up to here to a height of 4. And then the last one, this is removable, because clearly you can see this hole has been removed and pulled downwards. Okay, so 3 types of discontinuity we've talked about in the last video. We're doing it again here. So this is infinite, and it is infinite when at x equals 2. As x is approaching 2 from the right-hand side, the height is going towards, as x is approaching from the right-hand side, it's going up towards positive infinity. And as x is approaching 2 from the left-hand side, it's going down towards infinity. We can use limits to describe this behavior. So the limit of f of x, so this means as x is approaching 2 from the right-hand side, so positive always means from the right-hand side, and this would mean from the left-hand side. So the height limit of f of x is going towards, so this is right-hand side, so this is equal to positive infinity, and this one is equal to negative infinity. Therefore, for infinite discontinuity, so basically if the limit of f of x equals a positive or negative of that number, then as x is approaching, it doesn't matter what it's approaching. So then you know if one's positive and one's negative, one's positive, one's negative, then one's going up, one's going down, then you know that it's an infinite discontinuity. For this is a jump discontinuity, and it's jumping at x equals 0. So as x is approaching 0 from the right-hand side, f of x, the height is getting closer and closer to 0. And as you're approaching 0 from the left-hand side, the height is getting closer and closer to 5. So this limit of f of x is equal to, from the right-hand side, like we just said, well, basically we just did it right here. From the right-hand side, it's getting closer and closer to 0, and then from the left-hand side, it's getting closer and closer to a height of 5. So therefore, jump discontinuity. So basically, whenever you have two numbers that are going to be different, then that's jump discontinuity. So if one's approaching from the right-hand side is a different answer than approaching from the left-hand side, then you know it's jump. And this discontinuity is when it's going to be the same. So this happens to be removable. It's removable at x equals 2. As x is approaching 2 from the right-hand side, it's getting closer and closer to a height of 2, and it's coming closer and closer to a height of 2 on the left-hand side. Now, when x equals 2, the answer is 4, but that's not what it's getting closer and closer to. So that's what we use for this. So we can say to describe this behavior. So basically, when they're equal to the same thing as I had just done a second ago, then we know that it's it's removable discontinuity. Jump would be two different numbers. So if one's going positive, one's going negative infinity, then you know it's infinite. And when they're the same, then you know it's removable. And if they're two different numbers, then you know it's a jump discontinuity, which was the point at the bottom. Okay, so as x equals 0, so what if it's continuous? So if it's continuous, like in this case, well, it's going to have the same as well. So as you approach 0 from the right-hand side, it's getting closer and closer to 0. And you approach it from the left-hand side, it's also going to be getting closer and closer to 0. This function is continuous. There is no jump in this case. There's got to find discontinuities using limits. So this is infinite because we know the limit of f of x as x is approaching 1. Then we know the answer is from the right hand side we would say it's getting closer and closer to positive infinity, and if I did the exact same thing from the left hand side, the limit of f of x towards negative infinity is the answer as x is approaching 1 from the left. This one it's going to be the same, so as the limit of f of x is going to be 1 when x is approaching -1 from the right and the left. I would just write the exact same thing with a 1 with a minus sign. Limit of f of x equals 1 when x is approaching -1 from the left hand side. Okay, so this one is a jump discontinuity, so the limit of f of x as x is approaching 2 from the right hand side, it's getting closer and closer to 6, and the limit of f of x as x is approaching 2 from the left hand side is getting closer and closer to 4. So we got two different numbers here, and which once again tells you that it's a jump discontinuity because it's going to two different places. So basically, what if I told you the discontinuity? Could you tell me, type of discontinuity it is? Could you tell us what the result is? So suppose that the limit of f of x as x is approaching -1 from the right hand side, the answer is 2. Well, if it's removable discontinuity, you remember that it's going to be exactly the same. So this would also be 2. So whether or not you're approaching -1 from the right or the left, if it's removable discontinuity, you know it's going to be the exact same number. If it's jump discontinuity, then you know it's going to be two different numbers. Instead of 2, it's going to be something else. And it told you over here that the value of f of -1 is 0, which means that that's the other place where it is. So therefore, you know, if you approach from the right-hand side, it's 2. And if you approach from the left-hand side, if it's jump discontinuity, which means it has to be different than the 2, which means it has to be this other answer. Okay, and last one. So we're given some characteristics of the function. We're being told to graph that function. So if we told the domain is from -infinity to -2, so that's anywhere from over here to -2 is where it stops. So I'm going to put my dotted line right there, and then it picks back up again at -2 and goes towards infinity. So we know that there's a break. This is definitely an asymptote. The limit of f of x is equal to 1 as we approach to the right. So the further and further we go to the right, it's getting closer and closer to 1. So I'm going to put a dotted line here, and we come from the left, it also gets closer and closer to 1. So we know it's a rational function in this case. Well, actually, it told us up there. The limit as x approaches -2 from the right-hand side is going down towards infinity. Okay, so we know it's like this. Because this side, remember we said, is getting closer and closer to 1. This side's getting closer and closer to -infinity. And it looks like this side does exactly the same thing. As we go from the left-hand side closer and closer to a value of -2, it's also getting further and further down towards infinity. All right, that concludes the video. Thanks again for watching. Please give it a like to help you learn something about doing limits and using them for the 3 different types of discontinuities. Thanks again for watching. Have a great day.